Hey everyone, so this video is going to be a technical reference guide for Voxel Framework. I will probably do a total of 3 in this series. I was trying to do just one video, but I kept rambling. So this one will be the core fundamental functionality of placement of blocks, which obviously is the basic reason a voxel modeler exists. And then the other 2 videos will be like how to modify color, how to delete, and then how to make the larger shapes. Let's take a minute to quickly look at the notes. This basically contains the licensing. So this is non-exclusive, so everyone can use it. You can use it for any commercial or non-commercial. It's free to use. You don't have to attribute anything to me. There are no royalties. The only limitation is I reserve the right to distribute this core version. In other words, you can't download this and then immediately upload it and sell it. Your work needs to be a substantially derivative work. So in other words, you've turned it into an exe, you've turned it into a mod, you've added functionality. That's fine. That's substantially derivative and you can do whatever you want with. You just can't take this core version and then just re-upload it and sell it. But that's typical for Unity projects and typical for lots of assets. A couple of technical limitations. Right now, only 2 of the colors and the 3 textures work. That's because I didn't want to go through the effort of making dozens and dozens of colors, only for you guys to say there are much better colors and then have to redo that work. So I did just enough of the colors so you can see how it works, puts the functionality in place, and then you guys can build on that. So the color palette that you see for the most part are just placeholder. There is one other technical limitation. Right now, this can't be turned into an exe because there is an issue concerning Prefab Utility. Prefab Utility is how we take the object that is being made in runtime and turn it into an asset in your asset folder. It turns it into a prefab into your asset folder. So that's what we're using. And unfortunately, Prefab Utility prevents it from being compiled, built into an exe. So long term, we're going to have to figure out a way around that if we want to be able to make a standalone voxel modeler. But this could still be used within a Unity project to be able to do modeling inside of Unity without having to go to an external application. So you don't have to go out to Blender or something like that. Okay, so that's it for the technical notes. Now, as far as how this actually works, so as I said, this video we're going to look at block placement, and there's really 2 types. One, when you're placing a block on an empty tile, and 2, when you're placing a block on another block. Now, to understand how this works, you need to know that there are 3 variables that are controlling this. So if I was to run this, you can choose a shape. You can choose a meta shape, that is, it takes one of these and turns it into a larger shape. And then there's a tool, okay? So this variable is current shape. I believe this variable is meta shape. And then this variable is current tool. So those are taken into consideration when placing the block. So when you place on a block, you've actually set a number. You've set current shape to 0, to 1, to 2, to 3. I'll explain what that means in a minute. Here, you're just setting a string, and here you're also setting a string. Okay, so the tiles, they are actually just planes, and they're set at just under 1/10 of their normal size. So it's a plane. It has a mesh collider, and it has the script click check. As you can see, there's an array here, and this array are the individual shapes. So there's the block prefab, there's the block pyramid prefab, block wedge. Okay, so let's go back to a tile, doesn't matter which one. So it has the script attached. I do not use ray casting in this project. Everything is on mouse down, that I'm using the colliders and on mouse down to do everything. So let's go to that click check script. We're going to look at just the relevant part. So click check, and we're just going to go to the on mouse down section. Okay, so as I mentioned, if you click on one of the tools, it has to track which tool you've clicked on, so it's just a string. If you click on the plus sign, current tool is set to place, and now we can place an object. If the object that's being clicked on, because again, this is on mouse down, So the object that's being clicked on, if it contains tile, and all the tiles contain that, then it runs an instantiate command. So instantiate shape object, that's this. This simply says which one, because as I said, when you click on one of the shapes, it takes that click and turns it into an integer 0, 1, 2, 3. Why? Because that's the position in the array 0, 1, 2, 3. So that's what you're doing here. You're saying which shape to display. And again, when you're instantiating, you've got three arguments. What is being instantiated, where, and its rotation. So what's being instantiated? The one in the position of that number. Where it's being instantiated at the object the script is attached to. The script is attached to the tile, and therefore the position of the tile will be the position of the instantiated shape. And then what rotation? Since this is the tile and it's flat on the floor, the current shape's rotation. So these shapes, it says use its rotation. So use the current shape's rotation. This we'll cover in a separate video. This is a function that then decides, is this part of a meta shape? So are you making a line? Are you making a square? Are you making a triangle? So we'll cover that separately. So as you can see, the core functionality is pretty simple for the tiles. It gets more complicated for blocks. So let's do that next. Okay, so placement for blocks. Let's take a look at one of the blocks and you'll see why it gets a little bit complicated. As you can see, there are actually 6 planes. So when you're clicking on the block, you're actually technically not clicking on a block. You're clicking on a plane on one of the sides of the block. So that then functions very similar to the tile, but there's going to be a couple of changes, such as rotation. The way that I decided to use rotation to determine which direction it's facing, I created empty objects in the main scene that are facing in a certain direction. That way I knew that if I grabbed that rotation, it would 100% of the time be that object's rotation. I didn't have to worry about anything subjective or relative. I'm sure you guys can come up with a better way, but that's what I did. So I'm not using the rotation of the plane object. I'm using the rotation of these empty objects within the main scene. Again, that way I knew that it was an absolute value, that it was unchanging. So again, you can see that it's actually very similar. You've got a mesh collider, you have a click check script. Don't worry about the extra ones here. I was taking a different approach, but ultimately, if you wanted to create new shapes, that's what you would do. You'd put the new shapes, the new cubes here. So again, the big takeaway, you're not really clicking on the block when it comes to placement. You're really clicking on one of the 6 tiles. And they contain the direction that they're facing. So that's y positive, y negative, x positive, x negative, z negative, z positive. So you're going to see that in the coding. The coding is going to say, what is the name of the object you're clicking on? Does it contain y positive? Okay, use a certain rotation. Does it contain y negative? Okay, use a different rotation. So on and so forth. I think I might have skipped the y negative, excuse me, because it's underneath. Long term, I'll probably have to fix that, but I think that in the current form, I really ignored the y negative because I figured you would just be clicking some other way to get it there. Like you just fill it in from, you wouldn't actually click on the underside of something. So to do this right long term, we'll probably need to fix that. Okay, so let's now click back to our script. So again, you're really not clicking on the block. You are clicking on one of the panes surrounding the block. But this is where things get a little bit more complicated. Different shapes are treated different ways. So if you look at the block, you really should be able to click on all 6 sides. Also, it's symmetrical in every direction. Same thing for the block frame. It's very similar. It's symmetrical in all directions, and you should be able to click on any side. However, this isn't. So this would need to be rotated based on which side you're clicking on. So again, like I said, you have these empty objects, grabbing that rotation and applying it to this depending on which side you're clicking on. Also, when you try to build on top of this, let's open this up, you can see there's only one. So you can only build in that direction. So in other words, you can't stack something here or here or here. You can only stack something on top of it. So before I go into the tech anymore, let me just demonstrate what I mean. So say you've got this and you take this, it's automatically rotating it out like that. That's what I'm talking about, is that I have this 4 empty shapes. I'm grabbing that rotation of that shape and saying, based on the plane, because again, you're not clicking on a block, you're clicking on a plane. Based on that plane, which direction should this rotate? And you cannot click on top of this, you can only click on the side. So you can do that. So again, it's treated differently than the blocks. So the coding is predicated upon what shape are you clicking on and where on the shape are you clicking on. So hopefully I made that clear. My apologies if I didn't, but that's the whole idea, is that I'm having these predetermined rotations based on size. And with certain shapes, you can only click on certain parts. Like with this, I can't like click on the top and make another one. This one is basically a terminal shape that you can't go any further. Again, you guys might decide to change that, but that's why this coding is about to look weird, because it's looking at which way should it be inherently rotated and can you click and build in that direction. And just keep in mind, when you're looking at this, shape 0, shape 1, shape 2, shape 3, shape 4, shape 5, this is where it changes, because originally shape 6 and 7 were rotated versions of this. So this is actually shape 8, 9, and 10. And again, taking the idea of how the blocks are treated the same, the cones are treated the same, the cylinders are treated the same. So when you look at the coding, you'll see those kinds of numbering. So shape 0 and shape 8, those are the two blocks, the solid block and the frame block. So if the current shape is the frame block or the solid block, so it's saying here's the shape that you currently have selected. Now, based on what you're clicking, depends on how it gets rotated. Because it's the block, it really doesn't get rotated. It's always saying use the block's own rotation. Because again, it's symmetrical, so it doesn't matter. So whether you're clicking on the top or the bottom, so the top pane, the bottom pane, left or right, forward or back, doesn't matter. It's not getting rotated because blocks are symmetrical in all directions. So again, this is the shape that you have selected. This is the plane that you're clicking on. Where does it get instantiated? Now, obviously, if you're clicking on the sides or the front or the back, you need to move it. So that's just a half unity unit move, because everything is predicated on one unity unit. So one unity unit, X, Y, and Z. So this is moving half a unity unit out, half a unity unit down, half a unit forward or backwards. And again, it's predicated upon shape. So I have no doubt that you guys will probably come up with a more concise way of doing that. So it looks really, really codey, really kind of verbose at the moment. So you probably can find a way to consolidate this. And this is where I mentioned about the empty shapes. So you've got these 4 empty shapes here. And again, the reason why I did this is I wanted to make sure that regardless of anything else, I had a fixed rotation that I could apply. So this is simply saying, okay, if you click on XP, rotate it to that. If you click on XN, rotate it to that. If you click on ZP, rotate it to that. ZN, rotate it to that. Why doesn't the ZP and ZN not match? I think I made a mistake early on and then just never went back and fixed it. And since it works, as they say, if it works, if it ain't broke, don't fix it. So that's all that's happening, is you're taking the rotation of a shape and applying it to this shape. And that's all this is. It's just, again, looking at shape after shape after shape. Okay, so I think that's it for this first video. Again, this is meant to be the core placement of blocks, and we'll probably do 2 more that handle the changing of blocks as far as painting, deleting, that kind of thing, and one that handles the actual handles the making of shapes, and maybe one separate for the UI, but I really already covered the basics of the UI, and that is when you're clicking on a button, a number is being assigned to a value, and then that value, you already saw how it's utilized. So presuming you know how UIs work, you don't need me to do that. If you do need me to do that, let me know. But for the most part, these are just buttons that have a function associated. So if you don't know how to do this, leave a comment in the comment section and I could do a tutorial about that. But I didn't think you guys would need that level of detail because that's pretty straightforward. That's just basic UI. Okay, so that should about do it. I hope that you found this useful. Again, my apologies that I wasn't able to turn this all into one big video, but I kept finding myself rambling because, as you can see, you're kind of juggling. You got a few things going on, and it's easy to get lost even when you're the person who made the system. So again, I hope you found this useful. I already explained the terms of the licensing, so hopefully that is acceptable. And good luck with whatever you guys do with this. I had mentioned previously that once you guys start having something finished, whether it's a mod on the Unity store or it's an EXE on itch or wherever, that I would certainly be willing to consider sponsoring a game jam to promote it. I would probably even do a financial incentive. Like right now, there's a game jam where some company is giving away $2,500 USD if you integrate their bug checking software into your program. So certainly that is something I would be willing to consider to do. The only stipulation is that if I'm going to do that, there would need to be a free version. So maybe you have 2 versions of the voxel modeler. This one's free with limited functionality, and this one is paid with more functionality. And the game jam would be the only conditioned criteria for the game jam is you would need to use the free version and make a game based on that. And that way it would promote the game and get some exposure. Sorry, not promote the game, promote your application and get some exposure. So again, that's about it for this video. Please enjoy the rest of your day.